Hi students, welcome to physics classes. Today we'll discuss chapter heat. Heat is a form of energy which travel from higher temperature of the body to lower temperature of the body. Higher temperature of the body to lower temperature of the body. For example, if you have two bodies, one is having higher temperature, hot body, another one is lower temperature, cold body. When they are having contact, heat travel from higher temperature to the lower temperature, from A, which is hot body, to B, which is cold body. Heat is measured in SI units, joule, CGS unit, calorie. The relation between calorie and joule, 1 calorie equal to 4.186 joules. Now here we are using the word higher temperature to lower temperature. What does it mean by temperature? What does this mean by temperature? Temperature is the degree of hotness or coldness of the body. Means it is a measurement. How much extent the body is going to hot, how much extent the body is going to cool, that can be measured by temperature. Temperature of a quantity is measured by a device, thermometer. SI unit of temperature is Kelvin, CGS unit of temperature is Celsius. The relation between Kelvin and Celsius, 1 Kelvin equal to C plus 273, Celsius equal to K minus 273. That is because Celsius scale starts from water freezing point 0 degrees Celsius to water boiling point 100 degrees Celsius. Kelvin scale, water freezing point 273 kelvins to water boiling point 373 kelvins. Water freezing point is lower fixed point, water boiling point is upper fixed point. It is having 100 divisions, it is also having 100 divisions. Celsius scale is having 100 divisions, 0 to 100. Kelvin scale is having 100 divisions, 273 to 373. So 0 degrees Celsius equal to 273 kelvins. So if we want to convert degrees Celsius to kelvins, we should add 273. Kelvins to Celsius, we should subtract 273. Temperature is a scalar quantity. Temperature is a scalar quantity. Here we said heat travel from hot body to the cold body. When they are having contact, heat travel from hot body to the cold body. Up to what extent it will travel? It won't be continuously travel, no? Up to certain limit it is traveling. That is when both bodies attain same temperature. For example, if a body having 60 degrees Celsius is contact with another body B having 40 degrees Celsius. Now heat travel from A to B. Heat travel from A to B because A is having higher temperature, B is having lower temperature. Now heat travel from A to B. Up to what extent? Until their temperature is equal. Their temperatures become equal. For example, if A from A to B it is traveling, A temperature will be decreases, B temperature will be increases. Now if both attain same temperature, A 50 degrees Celsius, B also 50 degrees Celsius. For example, both attains 50 degrees and 50 degrees. Now which is hotter body, which is colder body? Both are having same temperature. So we can't say which is hotter and which is colder. So there is no transfer of heat. There is no transfer of heat. This situation, when both bodies attain same temperature, this situation is known as thermal equilibrium. Thermal equilibrium. Now, what is thermal equilibrium? When two bodies are in contact, if they acquire same temperature, if they attain same temperature, in that state, if you take any body, it is not able to receive the heat energy and not able to gives the heat energy. That situation, that state is known as thermal equilibrium. It is a state of a body where it neither receives nor gives out heat energy. It is not able to receive and not able to gives heat energy. In that situation, the body is said to be in thermal equilibrium. Now we know temperature of anything can be measured with the help of thermometer. Now when a thermometer is placed in a hot water, when thermometer is placed in a hot water, the mercury level rises. It starts rising because heat travel from water to the mercury expands on heat, so mercury level increases. Now when we will see the temperature, mercury level stops increasing. When mercury level stops increasing, we will see the temperature. Means in that situation, water and thermometer, water and mercury will have same temperature. That is thermal equilibrium. Means when thermal equilibrium is attained, we will measure the temperature of a body. At the situation of thermal equilibrium, we will measure the temperature of a body. Next topic, what is the relation between temperature and kinetic energy? Temperature and kinetic energy. To do that experiment, we should take food color or KMnO4 and two vessels, one is with hot water, another one is with cold water. Now we should add some food color to hot water and cold water. After few seconds, if you observe, the grains of the food color in hot water moves randomly, and in cold water is moving very slowly. We know that when the body is moving, when the particles are moving, it will have kinetic energy. energy. Here in hot water, the grains are moving very fastly when compared to cold water. Here they are moving very fastly when compared to cold water. So when they are moving very fastly, we can say it is having more kinetic energy. When they are moving slowly, we can say it is having less kinetic energy. So we can say when hot water, when temperature is more, its kinetic energy also more. When temperature is less, its kinetic energy is less. So we can conclude that average kinetic energy of the molecule is directly proportional to absolute temperature. When temperature is more, kinetic energy is more. When temperature is less, kinetic energy is less. Both are directly proportional. Both are directly proportional. Temperature is more, kinetic energy is more. Temperature is less, kinetic energy is less. Now, in the first topic, we discussed heat travel from higher temperature to the lower temperature. Heat travel from higher temperature to the lower temperature. Now, we will discuss an activity to show heat travel from higher temperature to the lower temperature. Activity to show that heat travel from higher temperature to lower temperature. To do this experiment, we need a glass tumbler, hot water, temperature is 60 degrees Celsius. We can take its temperature is 60 degree Celsius. Coconut oil at room temperature and a lid having 2 holes and 2 thermometers are the requirements. Now first we should take the vessel. Half of the vessel, less than half of the vessel is filled with hot water whose temperature is 60 degrees Celsius. This 60 degrees Celsius is not fixed. We can take still more, 80 degrees Celsius, 90 degrees Celsius also. Next, we should take coconut oil which is at room temperature, means less temperature. We should gently pour on the surface of water. We should make sure that they should not mix. Generally, coconut oil and water will not mix. Coconut oil will be top of the water. And we should take 2 thermometers. We can name A, B, and we should place it in one thermometer bulb, mercury bulb should immerse in water and another one should immerse in coconut oil, and make sure that these two should not touch. And thermometer which is placed in coconut oil should not fall onto the water. Name it as A and B. Close with the help of a lid. Close with the help of a lid. Now, if you observe continuously, the mercury level in the B, thermometer B, will decreases. Initially when we place it, it will increases and shows the temperature of water. And when we insert this thermometer A in coconut oil, its level will be increases and shows temperature of the coconut oil. Now after a while, if you observe, mercury level in the thermometer B decreases and the mercury level in the thermometer A increases. Mercury level in the B decreases, mercury level in the A increases. That shows kinetic energy of the molecules of oil increases and the kinetic energy of the molecules of water decreases. So we can say that temperature of water decreases, temperature of coconut oil increases. And we are not giving any heat here to increase oil temperature, coconut oil temperature. The temperature of coconut oil increased, that is because of heat traveled from water to the coconut oil. Heat flows from water to the coconut oil. So we can conclude that heat travels from higher temperature to the lower temperature. Heat travels from higher temperature to the lower temperature, from water to the coconut oil. So from this we can say temperature determines direction of heat flow, means which has lower temperature, in that direction heat will be travel. Here hot water, coconut oil, from water to coconut oil heat is transferred. Heat is transferred. Heat is the energy that flows. Here first we should take the aim. What is the aim of this experiment? To show heat travel from higher temperature to the lower temperature. Next, materials required: glass vessel, water at higher temperature, coconut oil room temperature, lid having 2 holes, 2 thermometers. Procedure: take a vessel, fill some of up to some certain limit with hot water, and above that hot water pour gently coconut oil and place 2 thermometers. One is in coconut oil, another one is in water, hot water. Now close it with the help of a lid. That is a procedure. Now observation: we can observe that mercury level in the A increases, mercury level in the B decreases. After few minutes, if we observe continuously, mercury level in the A increases, mercury level in the B decreases. That determines heat travel from water to the coconut oil. Water to the coconut oil. So we can conclude that heat travel from higher temperature to the lower temperature. Heat travel from higher temperature to the lower temperature. Thank you for watching. Please subscribe.